Hey everyone, and welcome back. Today we're going to be taking a deep dive into a pretty cool mystery.
Yeah.
One that's been puzzling scientists for almost a century now.
That's right.
And that's dark matter.
Mm-hmm.
We've got this really fascinating article that we're going to be looking at from SciTech Daily.
Okay.
It's called "A Nearby Supernova Could Finally Solve the Dark Matter Puzzle."
Wow. Pretty interesting title, right?
Yeah, and I think the clock is ticking because the supernova could happen like any day now.
Seriously.
Yeah, and we could miss a really huge scientific discovery.
Oh, wow.
If we're not prepared.
Okay, so what is it about this dark matter that's got everyone, on the edge of their seats?
Well, you see, dark matter is this invisible stuff, basically,
Okay.
that makes up a whopping 85% of the universe's matter.
What, 85%?
85%. We can't see it.
We can't see it.
No, we can't see it, but we know it's there.
Okay.
Because of the way it affects galaxies and how they move,
Oh, so we see its effects?
We see its effects, but we don't know what it is. So for like 90 years now, scientists have been trying to crack this code.
Yeah.
What is this dark matter?
Yeah.
And I guess one of the top contenders is this thing called an axion.
Exactly, the axion. It's a theoretical particle, but it's really intriguing because it fits in really nicely with our current models of physics.
Okay.
And not only that, but it could also solve another problem that we have in physics.
Oh, there's more.
Yeah. It's called the strong CP problem.
The strong CP problem.
Yeah. Have you ever heard of it?
I can't say that I have.
Okay. Well, basically, it asks why the strong force, the one that holds the atom together, seems to follow certain symmetry rules while other forces don't.
Okay.
And the axion, with all its unique properties, could actually provide an answer to that.
So this little axion particle could be like the answer to two of the biggest questions in physics.
Yeah, it's like a 2-for-1 deal.
Okay, but how do we even go about finding this axion?
Well, that's where supernovae come in.
Oh, okay.
Imagine, a giant star way bigger than our sun. Right.
Reaching the end of its life, and it collapses.
Okay.
Creating this huge explosion called a supernova.
Yeah.
And in the first few seconds of that explosion, a burst of axions could be created.
Ah, so these supernovae are like these giant cosmic particle accelerators,
Exactly. They're spewing out all kinds of particles,
right.
Potentially axions too.
Oh, wow.
And here's the thing. These axions would then interact with the supernova's magnetic field.
Okay.
Which is super strong, by the way.
Yeah.
And this interaction would convert those axions into gamma rays.
Into gamma rays.
Which we can detect.
Ah, so we just point a really powerful telescope at a supernova.
Yeah, just the right time.
And boom, we see the axions.
Well, we see the gamma rays that they produce.
Right, the gamma rays from the axions. Okay.
And that would not only confirm that they exist, but we could also figure out their mass.
Oh, wow. So it's like a fingerprint almost.
Yeah, exactly.
That tells us exactly what type of axion we're looking at.
But isn't it kind of a long shot, to rely on a nearby supernova happening?
Well, yeah, it is a long shot.
Yeah.
But astronomers think that a supernova visible to us happens about once every 100 years in our galaxy. And we do have these incredibly sensitive telescopes that are always scanning the sky, for this kind of thing.
So it's possible.
Yeah, it's definitely possible.
But I feel like we already missed a chance to do this back in 1987.
Ah, you're talking about supernova 1987A.
Yeah.
The last one we saw.
Yeah.
Yeah, we actually did have a gamma ray telescope pointed the right way.
Oh, really?
But it wasn't sensitive enough to pick up the signal.
Oh, so we had the telescope.
We had the telescope.
But it wasn't good enough.
It wasn't quite good enough.
Oh, that's rough.
Yeah, kind of a missed opportunity.
Yeah, big time.
Yeah.
Well, I mean, we must have learned from that, right?
Yeah, absolutely.
What are we doing now to make sure that we don't miss the next one?
Well, scientists are pushing for the development of better telescopes.
Okay.
Like Galaxis. It's a proposed constellation of space telescopes that would basically be watching the whole sky all the time.
So it's like a cosmic security camera.
Exactly. A security camera that never sleeps.
Okay, cool. But, I mean, supernovae aren't the only place where we might find these axions, right?
That's right.
What else is out there?
Researchers are now looking at neutron stars, too.
Neutron stars?
Yeah, like these extreme environments.
Okay, so what is it about neutron stars that makes them so interesting for this axion research?
Well, neutron stars are what's left after a star collapses.
Okay.
They're incredibly dense.
Okay.
They're like squeezing the entire mass of our sun into something only 10 miles across.
10 miles? That's tiny.
Yeah, they're tiny but incredibly powerful.
Okay.
They have these huge magnetic fields.
Oh, wow.
Trillions of times stronger than Earth's.
trillions of times stronger.
Yeah, and the temperatures are insane.
Yeah.
Millions of degrees.
Whoa, okay.
And all of this makes them perfect for Axion research.
How so?
Well, these extreme conditions could mean they're constantly producing axions.
Ah.
And because they're so dense, there's more material for axions to be produced and interact with.
Okay, so it's like these massive fiery neutron stars just constantly pumping out these axions.
Little axion factories.
And if we can just figure out how to detect them, then we might just unlock
one of the biggest mysteries in physics.
Incredible. So we've got supernovae possibly releasing these bursts of axions. And then we've got these neutron stars that could be just churning them out constantly.
Yeah.
But are there any other ways that we're trying to find these axions?
Oh, absolutely.
What?
There are these experiments happening right here on Earth.
Oh, really?
Where scientists are trying to directly detect axions.
Oh, so like building tiny supernovae in the lab?
Well, not exactly tiny supernovae.
Right.
They are trying to recreate those extreme conditions.
Oh, okay. So like in those neutron stars and stuff?
Yeah, exactly. Using some pretty powerful equipment.
So how do they actually do that?
Well, you remember how we were talking about axions interacting with magnetic fields?
Yeah.
Well, these experiments use really strong magnets to try and stimulate those axion conversions.
Okay, so it's like setting a trap almost.
Yeah, it does.
Using these magnetic fields as bait?
Exactly.
But how do they even know if they've caught one?
Good question. They look for a very specific signal.
Okay.
A photon with a very particular energy signature.
Like a fingerprint.
Yeah, like a fingerprint that tells them, aha, that was an axion.
Exactly.
But isn't it really hard to find such a small signal?
It is. It's extremely difficult.
Yeah, I bet.
It's like trying to hear a whisper in a really noisy room.
Yeah, like finding a needle in a haystack.
Yeah, but even harder because the signal is so faint.
Right. So what are some of the names of these experiments?
Well, there's the ALPHA consortium.
Okay.
They're using something called axion haloscopy.
Axion haloscopy. Okay.
It involves this incredibly sensitive detector.
That's designed to listen for those axion conversions.
So they're like tuning into the cosmic radio?
Yeah, you could say that.
Trying to pick up that signal?
Yeah, hoping to hear that little whisper.
Okay, cool.
Huh.
What else is there?
There's DM radio.
DM radio.
Yeah, they're using electric fields instead of magnetic fields.
Oh, okay. Interesting.
To try and stimulate those conversions.
So casting a wider net, basically.
Just trying different approaches.
Right. Different traps for the axions.
Yeah, exactly.
I like it. Any others?
Yeah, there's this one called abracadabra.
Abracadabra, like the magic word?
Yeah, it actually stands for something. It's a broadband resonant approach to cosmic axion detection with an amplifying B-field ring apparatus.
Wow. That's a mouthful.
It is.
Okay, so what does abracadabra do?
Well, they use a really strong superconducting magnet to create this powerful field, and then they look for these tiny fluctuations that could be caused by axions.
So they're like looking for ripples in the fabric of space-time or something?
Well, not exactly space-time, but they are looking for these incredibly subtle effects.
Okay, cool. And all of these different experiments are happening like all over the world?
Yeah, it's a global effort.
That's amazing.
Yeah, lots of collaboration going on.
I mean, have we found anything yet?
Not yet.
Okay.
But the fact that so many scientists are searching for them really says something.
It does, yeah. Like, why are they so sure these things even exist?
Well, axions weren't just, made up randomly.
Okay.
They were proposed to solve a specific problem.
Right. The strong CP problem.
Yeah, exactly.
So it wasn't just a guess they had a reason.
Exactly. They were trying to fill a gap in our understanding.
But even if they do exist, I mean, wouldn't it be super lucky to find one?
Well, luck always plays a role in science.
True.
But these experiments are designed to maximize our chances.
Okay.
Plus, even though they're hard to detect, they're thought to be really abundant.
So it's a numbers game.
Kind of, yeah.
More axions, more chances to find one.
Exactly.
Okay. So we keep refining our techniques and keep looking.
Exactly. It's only a matter of time.
Okay, but let's say we do manage to snag some axions from a supernova.
Yeah.
What would that actually tell us?
Oh, man, that would be huge.
Yeah.
It wouldn't just solve the dark matter mystery.
Yeah.
It would revolutionize our understanding of physics.
Okay. Like how?
Well, for starters, it would confirm that dark matter is made of particles.
Okay.
Which would be a massive step forward.
Right, because right now we have no idea.
Exactly. And it would also tell us a lot about the early universe.
Oh, really?
Yeah, like how galaxies formed.
Wow. So it's like finding a missing piece of a giant puzzle.
Exactly.
Suddenly, everything starts to make more sense.
Yeah, it would open up a whole new chapter.
And could it tell us anything about, like, gravity or the other forces?
It could. Remember, the axion was originally proposed to solve the strong CP problem.
Right.
So if we find it, it means our understanding of the strong force needs some work.
Whoa, okay, so it's not just about finding this particle.
Yeah.
It's about potentially rewriting the laws of physics.
Exactly.
That's mind-blowing. But even if we don't find axions, I mean, isn't the search itself valuable?
Oh, absolutely. We're learning so much along the way.
Okay, like what?
Well, we're developing new technologies, new detectors.
Yeah.
We're refining our experimental techniques,
Right.
and constantly pushing the boundaries of our knowledge.
So it's a win-win.
Yes.
We either find these axions and revolutionize physics, or we learn a ton along the way and make even more discoveries in the future.
Exactly. Science is all about exploration.
Yeah, it's true. But, okay, let's go back to these supernovae for a minute.
Okay.
If we do detect axions from one, what would that tell us about the universe as a whole?
Oh, that's a great question. It would be a monumental discovery.
Okay.
Not only solving the dark matter puzzle, but it would also change how we view the universe.
Okay, break that down for me.
Well, first of all, it would mean that dark matter, which makes up most of the universe, is actually made of particles.
Okay.
Something tangible.
Right.
Which would be a huge shift in our understanding.
Yeah. Okay.
And it would tell us about the early universe.
Okay.
How galaxies formed.
So, like a cosmic history lesson.
Exactly. And it could even affect our understanding of gravity.
Gravity.
Yeah, remember the strong force and the strong CP problem.
Right.
Finding the axion could mean we need to rethink some fundamental laws of physics.
That's incredible. So it's not just about the axion itself. It's about everything it connects to.
Exactly, the bigger picture.
But even if we don't find them, these experiments, they're still pushing the boundaries of technology.
Absolutely.
And we're building these incredible detectors. Learning all this new stuff about matter and energy.
It's all connected.
It really is. So it's a win-win situation. We either make this groundbreaking discovery, or we pave the way for even more breakthroughs down the line.
That's the beauty of science.
It really is. It's a constant journey of exploration.
Absolutely, driven by curiosity.
Yeah, and a desire to understand.
Exactly, and with axions, that journey is taking us on a cosmic adventure.
But there are still some big questions out there, right?
Oh, yeah, definitely.
Like what?
Well, like if we confirm these axions exist, what other mysteries could they unlock?
Ooh, that's a good question.
Could they help us understand dark energy?
Dark energy?
The force that's making the universe expand faster?
Oh, wow.
Or maybe even help us bridge the gap between quantum mechanics and general relativity.
Those are some pretty huge questions.
They are.
So even if we find them, the journey of discovery doesn't stop there.
No, it just opens up a whole new chapter.
Exactly. And who knows what else we'll find along the way.
You never know with science.
That's what makes it so exciting.
Exactly. It's full of surprises.
Yeah, totally. So we've talked about the science, the experiments, the possibility of finding these axions.
It's all very exciting.
But what does it all mean?
That's a good question.
Yeah, like, why should we as a species even care?
Oh.
That's a really good question.
Yeah.
You know, it's easy to get caught up
in
all, the details of the experiments, the what-ifs.
Right.
But why should we care?
Well, I think we have to take a step back for a second and think about it like this.
Okay.
Humans have always looked up at the stars and wondered about our place in all of this, Right. We've learned so much about the universe.
Yeah, you have.
About how it works, the laws of physics,
The Big Bang.
The Big Bang, all that stuff. But here's the catch.
Right.
All of that knowledge, all that understanding only accounts for a tiny fraction of what's out there.
Because most of it is dark matter.
Exactly.
It's like we're missing a huge chunk of the story.
It's like we've been reading a book.
Okay.
But we've only read the first few pages.
Right. Dark matter is like this whole new chapter waiting to be explored.
And axions could be the key to opening that chapter.
Exactly.
Okay. But how does knowing about dark matter and axions, how does that actually change things for us here on Earth?
Well, maybe not directly.
Okay.
But think about it this way.
Okay.
Every time we make a fundamental discovery in science, it leads to new technologies and advancements.
That's true.
Like think about electricity.
Okay.
When Benjamin Franklin was messing around with kites and lightning.
Right.
He wasn't thinking about iPhones or the internet.
No.
But look at where we are now.
Right. It all started with basic curiosity.
Exactly. So who knows what kind of breakthroughs understanding dark matter and axions could lead to.
It could be anything.
Exactly.
Okay, so that's the practical side of things.
Yeah.
But I feel like there's also something deeper going on here.
There is?
Like a philosophical aspect?
Yeah, it's about expanding our knowledge.
Yeah, pushing the boundaries of what we know about the universe.
It's that human drive to explore.
Exactly.
To understand our place in it all.
That's what science is all about.
Curiosity and wonder.
Yeah.
And that's something everyone can relate to. You don't have to be a scientist to appreciate that.
No, not at all.
So as we wrap up our deep dive into the world of axions and supernovae, what's the one thing you'd like our listeners to take away from this?
I'd say the universe is full of mysteries.
Yeah.
And the search for dark matter with this focus on axions.
Yeah.
It's one of the most exciting things happening in science right now.
Absolutely. It's like we're on the verge of a major breakthrough.
And who knows what we'll find.
Yeah, it's a reminder that there's still so much out there to discover.
So keep looking up.
Absolutely. Keep those questions coming.
Yeah.
Thanks for joining us on this incredible deep dive.
Yeah, thanks everyone.
Until next time, keep exploring.